All right, so section 2.7 is on graphing inequalities. All right, so you guys should have done these ones before. So graphing inequalities involve drawing a line and then shading above or below the line, right? So you should have done these in Algebra 1, hopefully. All right, so a linear inequality is a line with an inequality. So linear inequality is going to be either y is less than mx plus b, y is greater than mx plus b, yes? I think they're just observing. Hi, guys. All right, y is greater than or equal to mx plus b, or y is less than or equal to mx plus b. So it's the equation of a line with an inequality sign. Okay. So to find where to shade the inequality, so once you draw what I call the boundary line, you have to decide if you're going to shade above or below it. So to decide that, we usually pick a point that's not on the line. So when you guys have done this before, what's the point you always picked if it wasn't on the line? 0, 0, right? You pick the origin. So that's usually the best point. So to find where to shade an inequality, pick a point not on the line. So usually 0, 0. And you want to see if it makes the inequality true or false. If it's true, then you're going to shade that point. So you're going to shade 0, 0, and you're going to shade on that side of the line. Okay, so either above or below the line. Okay, it says the boundary line is dotted. So when I say dotted, that's like this. And the boundary line is solid, so filled in, if you have greater than or equal to, or less than or equal to. So it's dotted if you just have greater than or less than, no equal sign, because the equal sign would be the actual line. And it's filled in, so solid if you have greater than or equal to or less than or equal to. Okay, so it's pretty easy to do these. We just go through the same process. So first we graph the boundary line. So your boundary line is just y equals x plus 5. And in this case, the boundary line will be dotted because it was y is greater than, not greater than or equal to. So it's going to be dotted. All right, so I'm going to go up to my y-intercept, which is 5. 1, 2, 3, 4, 5. Some of you guys were messing that up on your homework too. You forgot y-intercept first. Some of you were trying x-intercept. So make sure you remember how to graph the line. The slope is 1, so up 1, right 1, up 1, right 1, up 1, right 1. All right, and it's going to be dotted. So if you can plan ahead, you'll save yourself some work by, a lot of people will draw a solid and then use their eraser, right? Especially if you have a pen. You just make it really dark. All right, so like that. All right, and then we decide if we're going to shade above or below. Okay, so we do a checkpoint. So we're going to check any point that's not on the line. So 0, 0, the origin, is not on the line, so it's good to check. Because then when you plug in 0, you get 0 is greater than 0 plus 5. 0 is greater than 5. All right, that's false. 0 is not greater than 5. So it can't be part of my solution set. It can't be one of the answers. Okay, so I don't shade 0, 0. I shade instead above the line. Now, some of you guys know a shortcut. If it is in the form y equals mx plus b, or the greater than, less than, whatever. So if it's in y is greater than x plus 5, right? So if I have the y isolated, then you can always say, oh, well, which way is the sign? Since it says y is greater than, you want all the y values that are bigger than that line. So you want above the line. Does that make sense? But if it said y is less than, then that would be below the line. So you can use that shortcut as long as you have it in the y equals mx plus b form, right? So y is by itself. So some people like to do that as well. All right, so let's try the next one. Okay, so how about if we have a different form? So we have 2x minus 3y is less than 6. So we're going to do 2x minus 3y equals 6 for the boundary. And that boundary is dotted again. All right, so I'm going to, it says it might be useful to use the intercept method. This is something that I usually ask on the test, not necessarily for inequalities, but for equations, right? So on your test, I would say x-intercept, y-intercept, And you'd have to find both of them before you graph. So a lot of you on your homework just kind of skipped over that. I asked you to find it with the x-intercept method, and you just like solve for y. So you can do that, but if I'm asking for the intercept method on your test, make sure you find both, okay? So the x-intercept, remember you plug in 0 for y. All right, so you go to your equation, and you basically take your hand and you cover up the y's. So I'm taking my hand, I'm covering up this y. So I have 2x equals 6. So 2x equals 6 means x is equal to 3. So I plugged in 0, and I got 3 for my x value. So it's a point, 3, 0. The y-intercept, we plug in 0 for, 0 for x. So for the x value. And all of this, I mean, you don't have to write these steps for x-intercept, y-intercept. You can do those in your head. It's really not hard to like cover something up and think what the x value is. Okay, so if I'm plugging in 0 for x, that means I'm covering up the x part. So I have negative 3y equals 6, so y equals negative 2. All right, so I plugged in 0 for x, and I got negative 2 for y. So 0, negative 2. So I have 3, 0, 0, negative 2. It's dotted. All right, and then I need to decide where to shade. So this is when you cannot just say, oh, I have in the equation less than. So since I have a less than, it's going to be below the line. Okay, you can't do that because you don't have y by itself. Okay, so you have to do a checkpoint when it's in this form. So we're going to check. So check 0, 0. When I check 0, 0, I get 2 times 0 minus 3 times 0 is less than 6, right? And again, you don't have to write out all of these steps. I'm just doing it for your notes. So 0 is less than 6. That's true. So that means 0, 0 will be shaded. So since 0, 0 is above the line, it's right there, you're going to shade above the line. That's your final answer. Okay, so the next one is y is greater than or equal to 6. So y is greater than or equal to 6. That boundary line is y equals 6. Right? That's the boundary line. It's solid. And y equals 6 is a horizontal line. Okay, so at 6, 1, 2, 3, 4, 5, 6, we're going to draw a solid line. So that's the boundary, but we had y is greater than or equal to 6. Okay, so I need to decide if I'm going to shade above or below. You can still do a point. You can still plug in 0, 0, even though you don't have an x value. You'd have 0 is greater than or equal to 6, which is false. So you know you have to shade above. But think about it logically. All the things that are in the shaded area are solutions, right? All of those points work in the inequality. So we want y values that are greater than or equal to 6. So where would they be? Right? Y values that are bigger than 6 would be up here, right? So think about that logically. You don't even have to do the check step there. Okay? And that was another one where y was isolated, right? So you could say greater than or equal to above. All right, next step. Okay, the next one looks a little bit more complicated. Okay, you could do it a couple different ways. You could go ahead and solve for y, or you could at least get rid of that 3/4 by either multiplying in or dividing by 3/4, and then using the x-intercept, y-intercept method. It doesn't matter. So let's say we forgot about the x-intercept, y-intercept method, and we went ahead and solved for y. Okay, so if I do that, you could multiply the 3/4 in, or you could divide by it, so you can get rid of it. So dividing by 3/4 is the same as multiplying by 4/3. So I'm going to multiply by 4/3 on both sides. So when I do that, the 3/4 and the 4/3 go away. They're gone. I'm left with the 8x minus 2y. A lot of people get confused on why the 3 or the 4/3 doesn't go into the 8x minus 2y as well. But think about numbers. If I had 2 times 3 times 4, you don't do 2 times 3 and 2 times 4 and then multiply them together, right? That's not the distributive property. 2 times 3 times 4 is 24, right? 2 times 12, 24. All right, it's not 6 times 8, 48. So you don't multiply it into both the 3/4 and this. You see what I'm saying? All right, so we get less than or equal to, so off to the side, if you need to do 6 times 4/3, you can. You can think of it as 6 over 1, so 24 over 3 is 8. Or you could reduce down, 6 and 3 reduced to 2 and 1, so that's how you get 8 as well. All right, so now we're here. So yes, you could do the x-intercept, y-intercept method. If I was going to do that, my x-intercept would be 1, my y-intercept would be -4, right? I'd have my line. So you can do that. But like I said, for your notes, let's assume we forgot we could do that, and we'll go ahead and solve for y. Okay, so if I subtract 8x, I get -2y is less than or equal to -8x plus 8. And I divide by -2. All right, this is always what I call the red flag rule. Okay, because we divided by a negative and we're dealing with inequalities. Okay, so what do I need to do? Flip the sign, right? So I'm going to flip it. So I have greater than or equal to now. So I have -8 divided by -2 is +4. And I have -4, and I get y. Okay, so I have y is greater than or equal to 4x minus 4. So I go down 1, 2, 3, 4 to -4. And my slope is +4. So I'm going to go up 4, right 1, up 4, right 1. My line is solid. And since I've isolated my y, I can now use that trick. Y is greater than or equal to. So when y is isolated, you can use this trick. So greater than or equal to, it means shade above. So you might want to write yourself a note, only when y is by itself or something. So you're going to shade this way. If you don't like doing that, you can always check 0, 0. 0 is greater than or equal to -4. That's true. So 0, 0 is part of your solution set. So it is shaded. All right, so the next one says the school carnival charges $4.50 for adults and $3 for children. The school needs to make at least $135. So when you hear at least $135, that's saying your amount needs to be greater than or equal to $135. Using X as the number of adult tickets, Y as the number of child tickets, write and graph an inequality for the amount the school needs to make on ticket sales. Okay, so think about this. If each ticket is $4.50 for adults, let's say I sold 10 tickets. It'd be $45, right, that you make. Okay, so we don't know how many tickets we're making or we're selling, so we're selling X tickets. So we're going to have $4.50 times X. All right, but we're also selling child tickets, so we're going to have 3 times Y. And that's the total amount of money that you're bringing into the carnival. All right, this amount needs to be greater than or equal to 135. Okay, then I solve. So you can solve for y, or you can use the x-intercept, y-intercept method. Personally, I like x-intercept, y-intercept for the graph, because you can see where it's crossing both axes. And it's going to be useful in a later section we do. So in chapter 3, 3.4, we'll be doing something similar to this. So we'll go ahead and do x-intercept, y-intercept method. Okay, so if I'm finding my x-intercept, I plug in 0 for y. So I get 4.5x equals, so we don't worry about the sign, just say equals 135. So when I divide it out, x is equal to, is it 30? Tell me what it is. Divide it out for me. Okay, 30. All right, so let's go by 10. So 10, 20, 30. So it's right there. All right, remember we plugged in 0 for y. That's why it's the point 30, 0. Okay, y-intercept. So for the y-intercept, we plug in 0 for x. So that means the x part's gone, so I just have 3y equals 135. And I divide it out, and we get 45. All right, so it's 0 for x, we got 45 for y. So 10, 20, 30, 40, 45. It's right there. So now we have enough information to draw in our graph. It's solid because it was greater than or equal to 135. And I feel like if you think about this logically, it makes sense. Any point, so let's say I pick this point right here, 10, 10. Is that going to give you an amount that's greater than or equal to 135? No, it's not. All right, it's the points that are above the line that are giving you what you want, because we want x values to be large and y values to be large to make a lot of money, right? All right, so you can plug in 0, 0, 0, 0 makes it false. 0 is not greater than or equal to 135, so we shade above. But in this problem, we actually have something that's a little bit wrong. Because the way that I've shaded it says that a point down here would also work. You guys see? And a point down there is not going to work because you're not going to sell a negative number of tickets. Doesn't make any sense. No freebies. All right, we're not paying people to go to the carnival, right? All right, so we actually can't have anything down there. So there's actually two inequalities that we haven't even drawn. So the other two are x is greater than or equal to 0 and y is greater than or equal to 0. And that will happen a lot in these like real life problems. All right, so x is greater than or equal to 0 means you have everything on the right side of the y-axis, right? X values are positive. Y is greater than or equal to 0 means you have everything above the x-axis. So your final answer ends up being here. Does that make sense? Okay. So any point in there will satisfy that inequality. All right, so part B says, if 25 child tickets are sold, how many adult tickets must be sold to cover expenses? All right, so we had 4.5x plus 3y has to be greater than or equal to 135. And we're saying 25 children are going to come. So I have 3 times 25. All right, I want to know what x has to be. So you solve. So 3 times 25 is 75, so 4.5x plus 75 is greater than or equal to 135. So 4.5x is greater than or equal to 60. So if you divide that out, x is greater than or equal to, it's like 13.3 repeating, I believe. Okay, so what's my answer? 14, yeah. Does that make sense? So it should be 14. So at least 14 tickets need to be sold. You can't give someone a third of a ticket. That's weird. All right, and the last thing we're going to do is graphing something that's not just a line. So maybe something that's an absolute value. So do you guys remember what an absolute value, what shape it has? It's not a parabola. That's what the first class was saying. Yeah, it's a V shape, right? So we have a V shape. So this is going to be some kind of V shape with shading inside the V or outside the V, okay? So what we do is we have a boundary again, but it's not a line. The boundary is y equals absolute value of x minus 2. And it is going to be solid because it was greater than or equal to. All right, so let's just do a t-table. So when we have absolute values, you always want to try positive numbers and negative numbers. So let's do 0, 1, 2, and then maybe -1 and -2 as well. Okay, so if I plug in 0, I have the absolute value of 0 minus 2 is -2. Right, the next one's absolute value of 1 minus 2. So 1 minus 2 is -1. The absolute value of 2 is 2. Minus 2 is 0. Absolute value of -1 minus 2 is 1 minus 2, which is -1. And the absolute value of -2 minus 2 is 2 minus 2, which is also 0. So I have 0, -2. I have 1, -1. I have 2, 0. I have -1, -1. And I have -2, 0. It's a solid line, so here is my V shape. All right, so I'm going to either shade inside or outside. Okay, so I want to, again, do a test point. So 0 is inside the V shape, so I'm going to check 0, 0. So I have 0 is greater than or equal to absolute value of 0 minus 2. So 0 is greater than or equal to -2. True or false? True. So we shade inside where 0, 0 is. That's it. Do you guys want to see more of those? Do you feel good about this section? Yeah, good. It's an easy one for the last section. It's not bad.